Okay, so in this video, we're going to look at 5 examples, 5 salts. We're going to determine if they are acidic, basic, or neutral. And if they are acidic or basic, we're going to write the hydrolysis reactions for them to prove that that's what they are. So the first thing that we want to do is we want to mentally divide them into their anion and cation. So it's the first thing you do. The second thing you want to do is you want to think about what ions are they actually. So for sodium fluoride, it's sodium ion and fluoride ion. Potassium chloride, potassium and chloride ions. Here we've got potassium and cyanide ions, ammonium and nitrate ions, and iron 3 and chloride ions. Okay, so if we think about our rules before, alkali metals have, they don't have protons to donate, and they will also not accept protons, so they have no acid-base properties in water. So any alkali metals are out. Oops, that's not an alkali metal. So these are not going to contribute. Okay. So then the next thing we want to think about is that any anion that is the conjugate base of a strong acid will not have any acid-base properties either, because it will be a weaker base than water. Let me write these rules down for you because I think it would be good. Alkali metals do not donate H+, and they do not accept protons. So, no acid-base properties. And when I say no acid-base properties, I mean that they will not contribute to pH. It's going to be water. Okay, the next thing we talked about was conjugate bases of strong acids. So if we think about our strong acids, hybrohickyl high, honohickyl low, H2SO4, kind of looking through our list, chloride, that would be the conjugate base of a strong acid. Here's another one, nitrate, conjugate base of a strong acid. Let's see what others, bromide, iodide, chlorate, perchlorate. These are going to be weaker bases than water. So once again, they will have no acid-base properties. Water is going to be what's going to contribute to pH. So if we look at what we have left above, automatically I know that potassium chloride is a neutral salt because its anion and its cation are going to have no acid-base properties at all. If I look at the other 4, they are. So we will need to look at those individually. So if I remember what they were, I had sodium fluoride. This is pretty bad. Can't remember what they were. Okay, so sodium fluoride was one of them. Potassium cyanide, ammonium nitrate, and then iron 3 chloride. And we had eliminated the sodium ion, the potassium ion, the nitrate ion, and the chloride ion. So we were basically left with those 4 ions. So what we do is we take that ion and we write it plus water. Fluoride has no proton to give, so it will get 1 or gain 1. The hydroxide ion forms, so that tells me that the fluoride ion is basic. So sodium fluoride is a basic salt because it forms hydroxide ions in solution. Okay, cyanide ion plus water. Cyanide has no proton, so it's going to get one, which will give us hydrogen cyanide and hydroxide. The formation of the hydroxide ion tells me that cyanide is a basic anion. So I think, whoops, no, it wasn't sodium, it was potassium cyanide. Poisonous is a basic salt. Sodium fluoride, you've probably seen that in your toothpaste. Okay, let's take the ammonium ion plus water. Okay, you could say to me here, this does have a proton to give, and it could gain a proton as well. Well, if it gained a proton, you would get NH5 plus 2, which, just be practical, you haven't seen that. If it loses one, it becomes ammonia, which you have seen. Okay, the formation of the hydronium ion tells me that ammonium is an acid, so that means that ammonium nitrate, which is used in fertilizer and explosives, is an acidic salt. And then the last one, iron 3, is a transition metal. So it will form a complex ion. Water's going to act as the ligand. I'm going to double the charge on the metal, so it's 6. And then 3 plus 0 is positive 3. Now, this ion is what will react with water. So you'll have your complex ion, which is further reacting with the water that's present to give you hydroxide ion, is what's left over after this ion donates proton. So we get hydronium ion, and then we get this nice, scary looking new complex ion. The hydronium ion that forms, that tells me that iron 3 chloride is an acidic salt. Everything done?